In this chapter, we will be looking at some preliminary concepts in trigonometry. In this lesson, we will be looking at solving simple trigonometric equations.
So we're going to jump really quickly into just solving trig equations here, and I'll give you sort of a template to follow, and hopefully after a few of these questions you'll be like, oh my gosh, I know what you do next, because it really is the same thing over and over again. But before we jump into it, and it will be just in a couple seconds here, we want to just make sure that you're familiar with interval notation. Okay, so when we write 0 is less than or equal to theta is less than or equal to 360, another way that that can be written here is to put square brackets around 0 and 360. Now I know that sort of looks like a point, but it's all within context. Okay, in the where you would see that in your question, you would know that this has to be an interval. If you're not including one of the endpoints, so like right here from 0 out to 2 pi, but not including 2 pi, we would simply put a parentheses there. Okay, oftentimes you'll hear people call these hard brackets and soft brackets. Okay, or it's closed on one end, open on the other. Okay, and we see the same thing over here. Okay, you just put the parentheses around the 0, and then the square brackets on the 360 if you're including 360 but not including the 0. Okay, so again, just another way of writing those intervals, but it's something that gets used in higher levels of mathematics, so you should be familiar with it.
Solve the following on the given domains. Sine of theta is equal to negative 1 over 2, where theta is between 0 and 2 pi.
Okay, so the first thing that I'm going to do here is take a look at my domain, and I'm going to identify what it means. Okay, 0 to 2 pi means I'm starting on the positive x-axis and I'm rotating around a positive full rotation here. So there's nothing weird about that particular domain. It's something that you're already fairly familiar with. Then I come over here and I notice that sine is negative, and I know that sine is negative in quadrants 3 and 4. And so I'm going to be looking for a third quadrant angle and a fourth quadrant angle. Put those down here. Now I'm going to find the reference angle, and I get the reference angle by taking the inverse sine, or the second sine, of positive 1/2. Remember, I don't worry about the negative. The negative's already told me where I'm located. What I'm looking for is the size. Okay, the size of that particular reference angle. And now I'm in radians, and I recognize 1/2 is coming from the unit circle, so I go back into my memory and think, where does that? Pi over 6. Okay, so pi over 6. That's my reference angle. What the reference angle tells me is that I'm chopping the top half of the circle into sixths and the bottom half into sixths. Now, I know that my first answer should be in the third quadrant, so count that out from here. 1, 2, 3, 4, 5, 6, 7. So to get to the third quadrant is 7 pi over 6s. Now you might do that as pi plus pi over 6, and you'd get the same thing, but it's just as easy to count that out. In the fourth quadrant, here's my terminal arm, okay, so that the reference angle, this angle between the x-axis and terminal arm, is pi over 6, and I just count that out too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in the fourth quadrant, that is 11 pi over 6. And so those are the two answers that we're looking for.
2 cosine of theta minus root 2 equals 0, where theta is between 0 and 360.
Okay, and now again, the very first thing I'm going to do is identify what my domain is telling me. Okay, between 0 and 360, I start here on the positive and I rotate around, and again, this is just like the previous question, this is a positive full rotation. Now, I kind of have to do a little bit of work here to get the cosine by itself. I need to isolate the cosine before I can start solving this. So first of all, I've got two terms here. I'm going to bring the term that doesn't have the cosine in it over, so I'll bring over the root 2. Now I'm going to divide by 2. Okay, I can see right here that my cosine ratio is positive. Cosine is positive in quadrant 1 and quadrant 4. So I know I'm going to get a first quadrant answer and a fourth quadrant answer. Now what I need to do is get my reference angle, and I'll do that by taking the inverse cosine of that ratio. I don't need to worry about the signs because it was positive, so there's no issue there. And root 2 over 2. Do I recognize root 2 over 2? Yes, I do. Yes, I do. Root 2 over 2 and cosine is going to get me 45 degrees. Okay, I remember that link there. Now, in the first quadrant, the reference angle and the rotation angle are the same. So in the first quadrant, that's the easy one. It's going to be 45 degrees. Now, in the fourth quadrant, I would come all the way around to 360, but then I got to come back the 45 degrees. So it's going to be 360 minus 45, or 315 degrees. And those are our answers, 45 and 315.
Tangent of theta is equal to -1, where theta is between 0 and 180.
Now here's our first question that uses interval notation. And again, my first goal here is to just get a good sense of where is it you're asking me to look. So this is hard brackets on 0, hard brackets on 180, meaning we're really just doing this. This is just the top half of the circle. Now I'm including both the endpoints there. I don't know whether that's going to be an issue or not, but we are including the endpoints there. Now I look at my equation here. Tangent is negative. So I know tangent is negative in quadrants 2 and 4, which means I'm only going to get one answer here because I am only seeing my terminal arm intersect that domain once. So it's just going to be that second quadrant angle here. Now what I got to do, I know that I'm going to get a second quadrant angle here. Now what I need to do here is figure out what the reference angle is. And I will take the inverse tangent of 1, not -1. Negative told me what quadrant I'm in. I just want to know the size of it. So I just use the number here. And let's think about this. Now tangent is probably one of the more difficult ones, particularly if you've used the unit circle to memorize those ratios. If you use the special triangles, it's not really that much different than sine, cos, or tan, but on the unit circle, you have to think about the y coordinate divided by the x coordinate here. Now, to get a 1 would mean that the y coordinate and the x coordinate are the same, and that only happens at 45 degrees. So now, in the second quadrant, to put 45 degrees, remember you go up to 180 and then back to 45, okay? Or 180 minus 45, 135 degrees. So that's the angle being referred to by this question.
2 sine theta minus √3 equals 0, where theta is between -2 pi and 2 pi.
Now in this case, when I look at my domain here, this is a bigger domain than I've used for the last few questions here. So, but again, that's what we want to look at first. Now first of all, I'm going from -2 pi, which is a negative full rotation, and then out to 2 pi, which is a positive full rotation. So I'm going around the circle twice in this question. Once again, I need to isolate the sine function here just to get a sense of what it's equivalent to, because it's easier to solve. So there's two terms here. I'll bring over the √3 first. So 2 sine theta is equal to positive √3, and then divide by 2. So √3 over 2. Sine is positive. I know sine is positive in quadrants 1 and 2. And right there I can see I'm going to get 4 answers. 2 on the negative rotation, 2 on the positive rotation. So quadrant 1, quadrant 2. Now, I have to figure out what my reference angle is. And so that will be the inverse sine of √3 over 2. I am in radians. Now I got to think, what angle do I associate √3 over 2 with sine? Okay, what angle connects those two? Think to your special triangles, think to your unit circle, pi over 3. Okay, now the reference angle tells me that what I'm doing is chopping up the top half of the circle and the bottom half of the circle into thirds. Now that's a terrible, oh my gosh, look at that, that's terrible. Anyway, you get the idea. On the negative rotation, okay, I go out to the second quadrant, that's this one right here. On the negative rotation, that's going to be 1, 2, 3, 4 pi over 3s into the second quadrant, so negative 4 pi over 3. To get to the first quadrant, it's going to be 1, 2, 3, 4, 5, negative 5 pi over 3s to get out to that terminal arm. Now I'm going to jump over to the positive rotation, because those are the only two angles that are coming from the negative rotation. On the positive rotation, in the first quadrant, I get pi over 3. So there we go, pi over 3. And then just count it out. This is the arm in the second quadrant, so 1, 2. That's positive 2 pi over 3 to get me into the second quadrant. And there you go, there are my 4 answers right there.
Tangent of theta is equal to 0, where theta is between 0 and 2 pi.
Okay, so here we see that interval notation again. But let's just take a quick look. It's 0 and 2 pi closed on the two ends there, so it's just a full rotation. Okay, but we're in radians. Tangent is 0. Okay, well that's neither positive nor negative. So now this must be something weird going on here. And when tan goes to 0, that happens on one of the axes. Okay, so let's think about what tangent is. Tangent, the ratio here is the y coordinate over the x coordinate. Okay, now let's do ourselves a favor. Let's take a quick look at the unit circle and the important points here as we go around the unit circle. Okay, now tangent is 0. Tangent is the y coordinate over the x coordinate, right? Tangent of theta is going to be y over x. So now, in order for this ratio to go to 0, I need the y to be 0, not the x. If x is 0, this thing becomes undefined. So I need y to go to 0. So think about the unit circle here. Where does the y coordinate go to 0? Well, it goes to 0 here and here on the x-axis. Now, what angles are those? Well, it would be 0 degrees right here, and yes, my interval includes 0 degrees, my mistake, 0 radians. 0 radians. It also includes over here, pi, and then around a 2 pi. Now again, I have to look at my interval to make sure that that's included there, and it is. So the answers I'm looking for here are going to be 0, pi, and 2 pi to satisfy this equation. Okay, whenever you see stuff like that, the 0, the undefined, if it's sine and cosine you're looking for, then you're looking at the numbers -1, 0, and 1. Those are indications that you're working on the axes, what we call quadrantal angles.
Cosine of theta is equal to -1, where theta is between -pi and pi.
Okay, so in this question here, notice this interval right here. You should recognize that. We've looked at this one before. This is a popular one at the university. It's just a nice interval here because it's -pi, so negative half rotation out to a positive half rotation. This interval here covers the whole circle, but it uses the smallest numbers, if you will. Okay, so that's a good one here. So there's my interval right there. Now cosine is equal to -1. Okay, hold on a second. We were just talking about that. Cosine goes to -1. That indicates to me, remember, if it's 1, 0, or -1, that indicates to me that this is on the axes. So let's take a look at the unit circle. So terrible. 1, 0 right there. This is the 0, 1. This is -1, 0. This will be 0, -1. Now, I associate cosine with the x coordinate. Okay, now particularly on the unit circle. So cosine is the x coordinate of a point on the unit circle. So where do we go to -1? Well, in this case, there's only one spot, and that's right here. So look at my interval here. What angle or angles does that indicate here? Well, that indicates, okay, -pi and pi. We're taking a look at the negative x-axis. But the nice thing about this is that both those endpoints are included, so both those angles are included.
The secant of theta is undefined, where theta is between 0 and 2 pi.
Okay, so here we go. At this point here, we should probably be fairly familiar with what that interval is referring to. Okay, 0 to 2 pi, that is a nice full forward complete rotation here. Now, let's take a look at this here. Secant is undefined. Now, we'd mentioned just a little while ago here that these undefined 0, 1, and whatever, they happen on the axes. So I got to think about what this means first of all. Secant of theta is going to be the same as 1 over the cosine of theta. Now, this will be undefined so long as I've got some number divided by 0. That's what I'm looking for here. So essentially what this is asking here is, where does cosine go to 0? So again, let's take a quick look at that unit circle. 1, 0, 0, 1, -1, 0, 0, -1. So along the unit circle here, where does cosine go to 0? And that, again, we have to associate cosine with the x-coordinate. So the x-coordinate goes to 0 here at pi over 2, and then down here at 3 pi over 2. So those end up being my answers. Pi over 2 and 3 pi over 2 will make cosine go to 0, and at the same time, that will force secant to be undefined.
Root 2 times the secant of theta plus 2 equals 0, where theta is between -pi and 0.
Okay, so in this case here, our interval is again written in set notation. This one's not such a bad one here. This is negative pi, so it's a negative half rotation up to 0. And that's it. So just the bottom half of the unit circle here, the circle here. Now, I need to know what's going on here. So I need to isolate the secant. So there's two terms here. I'm going to bring the 2 over here first to get rid of that one that doesn't have the theta in it. So that's negative 2. And then I'm going to divide by root 2. So I'll get negative 2 over root 2. Now, notice it's negative. And we associate secant with cosine. Now, it might even be easier just to do this. Just to say, well, I don't want to work with secant, so I'm going to flip everything here. Secant is 1 over cos, so if I flip the left-hand side, I get cos. If I flip the right-hand side, I'm going to get negative root 2 over 2. Now, cosine is negative. I know that that's going to be true in quadrants 2 and 3. But the only quadrant that's of any interest to me is quadrant 3. So I'm looking for a quadrant 3 angle. I'm going to find my reference angle by taking the inverse cosine of positive root 2 over 2. I'm not interested in the negative. The negative tells me where it occurs. It doesn't tell me how big that answer is. But I know that I can associate root 2 over 2 and cosine together, and that's going to happen at pi over 4. That reference angle tells me that I'm dividing the top and bottom halves of the circle into quarters. If I'm in the third quadrant, that's my coterminal angle, and I can just count it out. 1, 2, 3. So this is going to be negative 3 pi over 4. That's the answer you're looking for.
Cosecant of theta plus 2 equals 0, where theta is between negative 180 and 0.
So now in this question, when we take a look at the interval, notice that we are rotating negatively through to 180 degrees, and again we're including the endpoints there, the negative 180 and the 0 degrees. Now we take a look at our trig function here, and again I'm going to isolate the trig function, so cosecant is going to equal negative 2. Now I can already tell because of the sign, I can get a sense of what quadrant this is going to be in, but let's reciprocate this. I'm going to convert this to sine anyway, so I'm going to reciprocate the left-hand side, which means I'm going to reciprocate the right-hand side. I see that sine is negative, and I know that sine is negative in 3 and 4. So in spite of the fact that I've got a very limited domain here, I am still going to have this, have two answers here. So I'm still going to get a third quadrant angle and a fourth quadrant angle. Now what I got to do is I got to get the reference angle. So the reference angle is the inverse sine of the positive of that trig ratio, because again I don't need the negative, I only need to know the size of the angle. And I got to think, okay, what angle connects sine and a half? And the answer is it's going to be pi over 6, or in this case 30 degrees. So now I follow along my terminal arm here, and this is going to be, sorry, not the terminal arm, I follow along the domain here until I get to my terminal arm. So in this first quadrant here, remember this is going to be negative 30 degrees, and that's quadrant 4, so negative 30 degrees. And then I go all the way around to 180 and come back to the terminal arm here. Okay, remember I want to always compare this to the x-axis, so I go forward to the x-axis and then come back. So negative 180 plus 30, negative 150 in quadrant 3. And there you go. Those are the two angles we're looking for here.
4 secant of theta plus 5 equals secant of theta minus 1, where theta is over all real numbers.
So now in this case, notice that the domain is now wide open. It's element of the reals, which means we're looking for, in this case, coterminals. Okay. Now I'm still going to take a look at what quadrants my answers are going to show up in, but I'm looking for coterminal angles at the end here. Now, in a situation like this, I'm going to do something here real quick here that's going to be a tool that I'm going to use a fair bit later on here when the question level gets a little bit more difficult. Okay, because there tends to be two levels to these types of questions. I've got a secant here and a secant here. Now, I don't know what secant theta is. I have no idea. So because I don't know what it is, for all intents and purposes, that's basically an unknown for me. So I'm going to replace secant theta with just an x, because this is going to reveal the algebraic issues here in this problem. Because there's a level of algebra that needs to be solved before I can even get to the trigonometry. When I replace secant theta with an x, I can see the algebra quite clearly. I'm going to now solve for x, so I'll subtract x from both sides, 3x I'll subtract 5 from both sides, equals 6. Divide, and I'll get x is equal to -2. Now, at this point here, I've solved the algebra. Now I'm going to plug my secant back in, my trigonometry back in. I don't really want to work with secant, so I'm going to reciprocate both sides, and I will get that the cosine of theta is equal to -1/2. Okay, now, cosine is negative, so now I can tell you that my answers here will be in quadrant 2 or quadrant 3. Okay, so I'm going to get my quadrant 2, my quadrant 3. Whoops, can't quite see that. First, I got to get my reference angle, though, so this is going to be the inverse cosine of +1/2. I am in radians. Okay, that's what the question says here. So I got to think, what reference angle connects cosine and 1/2? Well, the answer is pi/3. Okay, what pi/3 does as a reference angle, it tells me that I'm dividing the top half and the bottom half of the circle into thirds. Okay, to get into the second quadrant here, that's this arm, is going to be 2 pi/3s. To get into the third quadrant, that's this arm right here, is going to require 1, 2, 3, 4 pi/3s. Okay, now that doesn't actually answer the question, because what I need to do here is get my general solution. I have got two different terminal arms here that I'm working with. Okay, this guy right there and this guy right here. So I'm going to use the principal angle, the smallest positive angle, to get out to both of those. So I'm just going to list off the angles that I got, 2 pi/3 and 4 pi/3. And then I will indicate how they repeat, plus n 2 pi, where n is an element of the integers. Okay, that's how frequently that repeats. This is the answer over the domain, all real numbers.
2 cos theta is equal to the root 3, where theta is between 0 and 180.
All right, now back to a question. It's got kind of a standard domain here. We're just going to go from 0 to 180, including both the endpoints there, but that just indicates the top half of the circle. I am going to isolate my cosine here, and this is actually really quite easy to do in this particular question. I'll just divide by 2. Okay, it's kind of happy-go-lucky question. I've got cosine is positive. I know that happens in quadrant 1 and quadrant 4. However, I don't need quadrant 4 because my domain only passes through quadrants 1 and 2, so I don't even need that. I'm only looking for a first quadrant angle. Okie dokie. So now I'm going to take my inverse cosine of the root 3 over 2 to get myself that reference angle. And I got to think either with reference angle, with special triangles or with the unit circle, what reference angle connects cosine and root 3 over 2? And the answer in degrees is 30 degrees. And so now in the first quadrant, well, that's quite simple. It's just 30 degrees. Huh. That's the only one I wanted? That's the answer to my question.
Cotangent of theta is equal to root 3, where theta is between 0 and 2 pi.
So now as we're approaching the last couple of questions here, again, I hope you recognize the pattern here. The first thing I'm going to do here is identify what is the domain over which I'm looking. Okay, where am I looking around this unit circle? Okay, in this case it's just from 0 to 2 pi, so that's just a complete rotation, nice standard domain there to work in. Now I got to look over here. I've got a reciprocal trig function, so I'm going to reciprocate it, put it back in a form that I'm more comfortable with. I'd rather be working with tangent anyway. Tangent is positive in what two quadrants? Well, it's positive in 1 and 3. Okay, so I will be looking for a first quadrant angle and a third quadrant angle. Now I got to use my inverse tangent to find the reference angle. I'm in radians, so again I got to think special triangles, unit circle, what reference angle connects tangent and 1 over root 3? And again, tangent's always kind of a hard one to work with. If you're working with a unit circle, you've always got to think y coordinate divided by the x coordinate here, and y over x. Okay, when I think about the unit circle, that's going to be 30 degrees or pi over 6. Pi over 6 tells me that I'm chopping the top half of the circle into sixths and the bottom half into sixths. But I want an answer in the first quadrant. Now remember, it's always the terminal arm closest to the x-axis. So in the first quadrant, that is the reference angle, so pi over 6. To get to the third quadrant, remember it's the one closest to the x-axis, and so to get from here out to there, that's 1, 2, 3, 4, 5, 6, 7. 7 pi over 6. And so here are the two answers that I'm looking for in that given domain.
Find theta when the cosine of theta minus 10 degrees is equal to root 3 over 2, where theta is between 0 and 360 degrees.
All right, now this last question right here, we're looking for the answers in between 0 and 360. So just a nice complete rotation there. Nothing really odd about that. What's odd about this question is that little bit of algebra that happens right inside here. Now, I'm gonna slide us back a little bit here, okay? When we did this question over here, I replaced the secant theta with an x because I can see there's a little bit of algebra here that I got to do to get the secants together, okay? But this is happening kind of before the trigonometry, okay? So I'm doing the algebra on the trigonometry. Now this is different here because in this particular question, that little bit of algebra is happening after the trigonometry. This is within the function. So I'm going to actually do this. I'm going to replace this, let's say with a big old x here. So the cosine of x is equal to root 3 over 2. I'm going to solve this first, and then because this is inside that, I will move into this in just a little bit later here. Now, cosine is positive in quadrants 1 and 4. Okay, so I know I'm going to have a first quadrant angle and I'm going to have a fourth quadrant angle. I will get my reference angle by finding the inverse cosine of root 3 over 2. And again, it shouldn't take me too long whether I use special triangles, unit circle, or even my calculator to get that this is going to be 30 degrees. In the first quadrant, okay, that angle is going to be 30 degrees. In the fourth quadrant, again, I overshoot to 360 because I need to compare it to the x-axis, and then I come back to the terminal arm. So 360 minus 30, 330 degrees. Fabulous. That is not the correct final answer, and that's because I got to go one step deeper here. Now, from here, I take it down to this. Now, and actually I could help out a little bit here. I shouldn't have used theta here. I should have used x by mistake. This should have been x in quadrant 1, x in quadrant 4. Now, theta from quadrant 1 here minus 10 is equal to 30 degrees. Because remember what I'm replacing, I replaced theta minus 10 with x. So now I'm going to put that back. And to get theta 1, I am simply going to add that 10. So this was actually 40 degrees. This other one here, this x in quadrant 4 is equal to 330. Well, that's my quadrant 4 theta minus 10 is equal to 330. And now add that 10. And what I'm getting here is 340 degrees. Essentially what's happening here is we're getting this bit of a shift. Theta minus 10 is causing just a bit of a shift in the angles. So once I get my answers, everything shifts over 10 degrees. So the answer that I'm looking for here are 40 and 340 degrees.